Hello, today we're going to talk about how we can analyze our data when we do genetic crosses. We already know that we can predict the offspring with Punnett squares, so now we can actually analyze the actual experiments we do and compare it to what we should have seen in our crosses. So this is pretty much chi-square. This is the equation right here, and we'll go through this. We're going to define everything. We're going to be talking about the level of significance, and this just kind of shows you all of that. Okay, so this process, chi-square analysis, is going to allow us to determine if our data is biased or non-biased. So is it good or bad? And pretty much we want to see, based on the laws of probability, are our offspring following what we expect it to do. All right, and it will tell us if our data is good. So the chi-square analysis is what's going to be used for this. Again, this is the equation. This is the Greek letter for chi, so chi squared. This means sum, so you add everything together. O is observed, what we actually got from our experiment. E is expected, what we predicted from our Punnett square, and then we're going to divide that over expected. All right, so we make what we call a null hypothesis, okay? The null hypothesis will say that there's no statistical difference between observed and the expected values. So that would mean that it's a good thing. It's by chance alone. There's nothing really that's going to be happening, okay? If we support, our data supports the null hypothesis, then that is a good thing. That means that mating is random, normal gene segregation, independent assortment, all occurred. Things that we expect by learning meiosis and the genetics. If we don't support our null hypothesis, our data is different, all right, that means that there's something else that made it occur, something that's not random. So maybe it could be a linked gene or sex-linked or something else together. So we first need to figure out our degrees of freedom so we can analyze our data with a chart. Degrees of freedom is the number of phenotypic possibilities minus 1. So whatever we have as our options, we're going to take that minus 1. So if we have two different options, heads versus tails, our degrees of freedom will be 1 because it's 2 minus 1. And that's going to help us in using this data that we're going to get from the chi-square, and we're going to use a particular chart. And what we're going to be looking at is the 0.05 column, and you'll see that in a second. Okay, so here's just a hypothetical cross. This is a dihybrid fruit fly cross. This is showing you that we have a black body eyeless. This is recessive. So wild type is normal. So if we say it's wild type body and it has eyes, okay, so the recessive would then be the lowercase. Okay. When they do that cross, all the F1 generation are wild type, and they actually are the heterozygote. So now we did the following cross. We took the two heterozygotes and we crossed them together. And the below is what we get for our offspring. Okay, and you can see that when we counted up our data, we had over 5,000 wild type. We had wild type body, but eyeless was over 1,800. Black body, okay, and eyeless is this amount, and then just a black body. Okay, so now let's analyze these results. Okay, we know from doing the Punnett square, the dihybrid Punnett square, we should get a 9:3 to 3:1 ratio. Okay, so this is what is expected. So we have already what is observed, but we now need to figure out what the expected value is. So this column right here. And what we do is we take the number, we're going to take 9/16, and we're going to times that by this number, because this is the total amount that we had. And we would do that all the way down here. Okay? This is just showing you the different calculations. And again, we're just figuring out what we should have got based on the probability. Okay, this is what we expected. So these are the answers in the chart. Okay, and again, the null hypothesis is down there. Okay, so now let's calculate the chi-square. All right, so we take the sum, okay, of all the observed minus expected squared divided by expected. And when we do that calculation, we get 0.30. Okay? Now again, the degrees of freedom is always going to be 1 minus the number of outcomes. So we had 4 different possibilities. So we take 4 minus 1, and that gives us 3. So now we're looking for 0.3. And if you look here, this is where we are on the table. Okay? And that's a good thing. So you can see it's in the area of accepting the null hypothesis. That's pretty good data. At this point, right here at this line, all right, would be where we would start to reject it. So if our number was 7.82, we would start to reject that. Okay? So now we're going to be able to analyze the table, and this just goes through exactly what I just said. Again, we found those 3 degrees of freedom, and because it was 0.3 the chi-square value, it was 95%. Okay? Which means that it is a good value. We're going to accept our null hypothesis. Okay? And then this shows you where we're going to start to reject it, and then just some analysis questions. And this is how you would write your results. So, if you have any questions, please see me. Thanks.